So let's just look, I'm on page 11 of your notes packet. If you would pause if you're not there, and then let's look at these rules for exponents. I'm not going to spend a lot of time on this because I know you know how to do this. Anything to the 0 power is 1. Make sure you know that. If you have a negative exponent, remember that's the same as this thing being positive with a positive exponent as long as you make it a fraction. Okay, so remember you can change spots. So this is technically over 1 here. You can flip it and that will make that exponent positive. Anything to the first power is itself. This is basically saying that if I had, let's say, the square root of x, okay, that's equivalent to x to the 1/2 power. Okay, because remember power over root, so your power is technically a 1 here. There's where that 1 comes in. And this is a square root, so there's a 2 here, so you'd have a 2 there. Just let me give you another one. So like if I had the cube root of x, then that would be x to the 1/3, okay? Because again, the power of this x is a 1, that's where that 1 comes from, and the root is a 3. So power over root, okay? If you think you're going to forget that or you want to remember that, power over root. All right, next thing is you should know when you have the same bases, we add the exponents. When we have the same bases and we have division, we subtract the exponents. And when you have one base, but then you have 2 powers here, we're multiplying those exponents. So make sure that you have that all set. All right, now let's look at the bottom of that page 11, and let's start one of the questions. Okay, so let's look at number 3. So we have what we call an exponential equation, and basically all an exponential equation is an equation, and our exponents have variables in them, okay, for this particular example. All right, so the way we do this is we're going to do a little bit of math magic. What we want to try to do is make these base numbers of 9 and 27, we want them to be the same number. So let me show you how we do that. So basically what you're going to do is I'm going to make 9 and I'm going to change it to 3 to the 2nd power, right? Because 3 to the 2nd power is 9. Now, you might be asking me, why am I doing that? Hold on. Then what I'm going to do is, in parentheses, I'm going to put the original exponent of that 9. Okay? All right, so here's where it may start to make sense to you. Then I'm going to take 27 and I'm going to say, oh, well, 27 is 3 to the 3rd power. And then I'm going to bring down the original exponent of x plus 1. So here we go. Like I said, we want this 9 and this 27 to be the same number. So I thought of a number that goes into both 9 and 27, which is 3. And then I was like, okay, well, 3 squared gives me 9, and 3 cubed gives me 27. Now, there's a reason why I do that. Because if you have the same base number, now you can cancel them out. And that is why we're doing what I just did. You want those base numbers to be the same, because then you cross them out, and look at what you have left. 2, parentheses x plus 2, and then 3, parentheses x plus 1. Super duper easy, right? It's like algebra 1. So now we're just going to distribute, and we get 2x plus 4. Make sure you're taking notes. And we get 3x plus 3, right? So I'm going to subtract this 2x over, and that's going to give me 4 equals x plus 3. And then I'm going to move that 3 over, and I'm going to get x equals 1. And there's your answer. So not so bad. You just have to get the bases to be the same, and that's the kicker right there. All right, so now let's look at number 4. Do not panic over the fact that we've got a fraction here. Pretend the 1's not even there. Pretend you have 4 and you have 8. So let's do it like we did number 3. And I would think 2, right? 2 goes into 4, 2 goes into 8. So I would say, all right, 2 to the 2nd power is 4, isn't it? And then 2 to the 3rd power is 8. and then I'm going to bring down the x minus 2. Okay, so now listen. In reality, I cannot forget that this is a fraction. But if you recall at the top of the page, look at the second line down on the left-hand side. It says x to the negative n power equals 1 over x to the n. So how do we apply that to this? Okay, you ready? I'm going to put it in red. That's how we apply it. Okay? Because, and I'm just going to do this off to the side, 2 to the negative second power is the same as 1 over 2 to the positive second power. And isn't that 1/4? Voila. Okay? So this is my advice to you. When you have a fraction, all I want you to do is just look at this number right here and deal with it as if it wasn't a fraction. So if you look at what I have in black right here, we just did 2 to the second. And then if it's a fraction, all you do is negate your exponent, and then you're good to go. Okay? So now I'm going to go back over here. I'm going to be like, oh, same bases. They're gone. So now I have negative 2 equals 3 times x minus 2. Okay, let's do a little bit of distributing. So I've got 3x minus 6. I'm going to add my 6 over. Oop. So I have 4 equals 3x. And then I'm going to divide out that 3. And so I have x equals 4/3. And that's it. Okay, make sure you're writing this in your notes packet. Okay, now here in number 8, so just turn the page. Number 8, this is a different type of exponential equation because we do have an exponent, but it doesn't have an x in it. So go back and look at number 3 and 4. Those were exponential equations as well. There were exponents, but the exponents had x's in them. This is the opposite. Our base has the exponent. So because it's slightly different, we're going to have a slightly different rule. So I'm just going to rewrite this. So x plus 5 to the 3/2 power equals 8. Okay, so let's just think of the laws of solving for x. You always have to get rid of whatever's attached to it, correct? Well, I know I have to get rid of this 5, and I know I'm eventually going to subtract 5, but I can't do it right now because it's tied into this exponent. So we have to get rid of this exponent. And I don't know, you should remember, when we want to get rid of an exponent, all we do is multiply by its reciprocal. But since it's an exponent, when I multiply over here with the 8, I'm going to keep it as an exponent. Do not do 8 times 2/3. You're going to do 8 to the 2/3. Okay, and what that's going to do here is get rid of that exponent. Okay, and then I'm going to get x plus 5 equals 8 to the 2/3 power. Now remember, power over root, right? So the root is 3. The power is 2. So I've got x plus 5 equals, now, cube root of 8 is 2, and then 2 squared is 4. So this is going to be 4. And then all I do is subtract 5. So x equals -1. All right, so again, we're not doing what we did the last time because our bases the last time were both whole numbers, or I should say numbers. Where we don't have that, right here, this base is not a number, it's an expression that involves a variable. So when that happens, all we're going to do is get rid of the exponent by multiplying by its reciprocal, exponent, do power over root, get that answer, and then, be on your merry way. Okay, so let's look at number 10 because it's similar. Now number 10, the difference is, though, if you look at this, okay, x is to the 2/3. We can get rid of this plus 1 because there's no parentheses here like there was on the last question. Okay, so I'm just going to go straight to it where I'm going to subtract 1 and subtract 1. So that's going to give me x to the 2/3 power equals 64. All right, now remember how we get rid of exponents. We just multiply by the reciprocal, but make sure it stays an exponent though, okay? this will disappear. And then on the left-hand side, we're going to get x equals, and we've got power over root. So we've got the square root of 64. Technically, there's a 2 here. You can write it. You don't have to. And then we're going to cube that. So the square root of 64 is 8. And then I'm going to cube that. Okay, so I'm doing 8 times 8, which is 64, and then 64 times another 8, which is 5/12. And there's your final answer.